First of all, thank you for choosing my talk. I know there are a lot of great talks at the moment happening right now, so thanks for choosing this one. Also, I know that it's beautiful weather outside, so thanks for choosing to be here instead of outside on beautiful sun. So, welcome to my talk, GraphQL versus traditional REST API. First of all, let me introduce myself. My name is Vladimir Dejanovic, and I'm part of professional IT scene since 2006. In other words, I'm getting paid for writing code since 2006, and I wrote code in many programming languages. I worked on all kinds of projects over the time. Also, I'm a founder and leader of Amsterdam Java user group and speaker at conferences. But enough about me. What this talk is going to be about. First, I will spend some time talking about the REST and what the REST APIs are, and more precisely traditional REST APIs. Then I will spend some time with GraphQL, and of course, on comparison between those two. At the end, there will be some time for questions, so if you have any questions, please wait until the end, or you can always ask me via the email or Twitter, because after the talk I have to run. So, what is REST? This might sound like a silly question, right? A lot of us are developing REST APIs all over the time. It's not a new thing, so why should I start with a question like that? Well, there is a very good reason for it. If I really would ask this question, and I would get a lot of answers, and unfortunately, most of them would be wrong. And the reason for that is that REST has a very formal definitions, since it was part of doctoral dissertation by Roy Fielding. If you would like to read the whole dissertation, this is the URL, and I recommend it very good to read it. It's very good, but it's very long for this talk, so we will not go into all the details. So we will look at a very short version of it. So in order for some API to say that it's REST API, there needs to be client-server architecture. So there's a client and a server, separation of concerns. Statelessness. Server should have no clue about the state from the client. All the data that the server needs to respond to the client needs to send in a request. Cacheability. Server should be able to send, okay, this response should be cached and for how long? Layered system. Client should have no clue if it's talking directly to the server or it goes through multiple layers before it actually reaches the server. Code on demand, well, it's optional. In theory, it means that the server can send arbitrary piece of code to the client which it should basically run. And last but not the least is the uniform interface. Actually, in a short way of saying it, it means that different parts of a system can evolve independently. Okay, but that's all nice, but my clients don't care really about theories and doctoral dissertations, and I doubt that your employer also care about that. They care about working code which actually solves some problems in real life. So what do we think about REST in real life? Well, usually it means that there is some data source. Probably a database, right, where some data is stored. Then there is our API, basically, which talks to the database and exposes the data to the front end. Sometimes this is done like literally field by field. Whatever is in database is going to be taken and shipped to the front end without any transformations. Sometimes there's more complex cases, but in most cases, it's just going to be like field by field, or so-called crude REST APIs. So imagine we have some blog that we want to write, right? So some real use case scenario. And we have authors, which have ID and the name of the author. This one table, database. Then the other table would be, okay, we have posts, right? They have ID, title, body, and author ID. And we will have a little bit of more advanced features like comments on the posts. So we can also add comments, and the comments will consist of ID, text, post ID, and author ID. So how would this look actually in the code? This is the URL that I'm going to use throughout the talk. I'm just going to use basically different tags for different parts of the talk. Example which I'm going to show you is Spring Boot with MongoDB in the backend because I'm a lazy person, and those two things allow me to actually create the prototypes very fast, very easy. So let's look at the code. So first things first, I have a post Pojo, which is actually a representation of a database. And as you can see, it's exactly the same like the table that I showed you. So I have an ID, I have an author ID, title body. If I open post repository, again, this is Spring with the Mongo repository, so it's very easy. I just say Mongo repository, and you do everything for me. The similar thing is with the author. So if I show you the author, again, nothing fancy here, right? I have an ID and a name, exactly the same, like a table. Again, author repository, exactly the same. Very simple thing, comments. Again, the real part of the code, basically the, so to say, business logic in this case, is in my controller, which is again, of course, REST controller. Thank you, Spring, for all the good annotations. So, and then basically I have endpoint authors, which will return me all the authors. If I want author by ID, I just hit like this. Then for all posts, I just have like /posts, that's it. I have option, if I manage to do this, to filter by author ID. Again, I have all comments, or I can ask for comments by post ID. So it would, yeah, not like that. So if we go here and so posts, right? Ooh. Is this better? Yeah. Okay, so basically I can hit all the posts. I can see, for example, first post has an author of 1, 2, 3. So let me check who's the author 1, 2, 3. Authors. I get the idea about the author, and also I can ask for comments for this post. And I get comments, right? So it's really enough. You can build the whole website and front end with the REST API like this. Okay, so let's move on. So now the question, what is GraphQL? First thing which actually what I did when I heard about GraphQL is I went into Google, put GraphQL, went to the official website. And this is what I found. GraphQL is a query language for APIs. And I was like, okay, what does that mean? So I continue reading what's there on the website, and I come to the answer. And the answer is very simple. GraphQL is a specification. Nothing more, nothing less. And it is important to remember that GraphQL is specification because we, as developers, are not building code with specifications. We're building our code with implementations of a specification. And there are specific implementations in JavaScript, Java, PHP, Go, and new implementations are being built daily. Important thing to remember is that when you develop the code, you will use some implementation of those languages. And some of those implementations will basically cover whole specification, some will cover part of specifications, and some will add some specific things to it. So you need to be aware which implementation you're using and what are your limitations and specific flavor to it. I will be using Java implementation, which is called GraphQL Java, in the rest of my codes and demos. And also I'm going to use some other, so to say, module which actually helps me to write a little bit more compact code. So again, talking is boring. Let's look at some code. Again, same URL, different tag. So let's go to that tag now. Okay, while this starts up, let me show you the important part in the code. So first thing first, which I want to show you is like I'm using the same post. So the same Bojo, the same repository, the same author. So nothing changed there. It's exactly the same. But I added some stuff for the GraphQL. The first thing is schema. If I hate this. Okay, I need to refresh and hopefully then it will appear. Yes, now it appears. Okay, so the first thing that I have here is basically GraphQL schema. And this is a very important part of GraphQL. And here basically I define, okay, how my GraphQL API will look like. What are the things that actually I can expose? And I have type of the author, and you can see it's exactly the same like Pojo, right? So exactly the same like a database. So ID, name, right? IDs of type ID, in theory it means string, but not humanly readable. And this exclamation mark here means that this field is mandatory, so it can't be null. Again, I have name of a type string. In similar way, I define the post. Again, exactly the same like a Pojo, exactly the same like a database, so nothing changed. Same thing for comments. And now, let me just bring this up so that everybody can see. And now, basically, we come to the heart of the GraphQL. This is the schema. This is the entry point into our GraphQL. And here I say, okay, I will have a query of type query. And type query is again defined like exactly all the other types that I showed you. So exactly the same manner. I have all posts, and here I have array of posts. So for this to make it work, I need to do next thing. So first I need to define the servlet and say, okay, on the entry point /GraphQL, open the servlet. And in this case, I'm using, like I said, the classes that actually help me to write more compact GraphQL code. So here I just say, extend simple GraphQL servlet, and I get a lot of things for free. And below this one is GraphQL. An important part here is that I say schema parser, new parser, and here basically I provide my schema definition. So in this way, basically, I'm connecting my schema and wiring with the Java code. So I say, okay, like this is the schema that I need to wire with the whole Java code. And I'm wiring it here below with the resolvers. So I say, okay, add resolvers. In my case, I have only one resolver, query. And afterwards, I say build and make executable. That's it. So let's look basically what the query does. So the query implements GraphQL root resolver. And this is important for every resolver which is on the top level of the GraphQL. And here you can see I have a method of the funny name allPosts, which return list of posts. So first thing first, this is called query, and in schema it's called query. It's not by accident. It's on purpose. So in that way, basically my Java code knows how to wire with the GraphQL schema. The same thing. Here I have all posts. Here I have a method called allPosts, which will returning the list of posts. Again, it's intentional so that my Java code knows how to wire itself with the GraphQL. Okay, all of this is nice, but what does it mean in real life? Well, in real life, it actually means this. So, okay. So here I'm using GraphQL, which is like a demo client, so to say, a playground for the GraphQL. And here I can say, okay, query, and I have autocomplete. Say all posts, ID, title, body, and author ID. And I can just run it, and voila, I get exactly the same thing like the rest previously. So not really that big of a deal. The nice thing that I can do here out of the box is I could just remove the fields which I don't want, and it still is going to work. So I get filtering for free with GraphQL out of the box. Again, you can implement this with a REST API, so questionable. Another nice thing here is I have documentation for free. So I can basically see, okay, here I have query, and I can request it. I will get method of all posts, which will return the posts. So a lot of things you get for free, which is nice. Okay, let's go back to the slides. So let's just do the quick check how the GraphQL compares to the definition of the REST. Client server, well, yeah, I showed you the client and the server, so checked. Statelessness, well, it depends how I implement GraphQL API, so in my case, yes. Cacheability, well, I use the simple Java servlet, so yes, I can do this part. Layer system, again, checked. Code on demand, well, it was optional from the start, so automatically checked, right? And then the uniform interface, well, I showed you the schema. So I would say yes. So I would argue that the GraphQL is a REST API. but not any API. The GraphQL is very advanced API, and I will come back to that later. So with REST, as we all know, schema is optional. You may write the code and then generate the schema from it. You can write the schema and then generate the code from it, or you can completely don't do anything with the schema. Everything will still going to work because it is an optional. I would advise you to always have a schema because it is extremely good practice. But again, even if you don't have it, everything will work. With GraphQL, it's a different story. And this is the first big difference between GraphQL and REST. In GraphQL, schema is mandatory. You must have it. You can do what I did, create the schema, and then basically create the code which actually wires to the schema, or you can do either way around. You can first create the code, and then from the code generate the schema. It doesn't matter which way you go. In the end, you must have schema. Schema is mandatory. Reason for that is very simple. And that is if you have a client, and the client connects to the GraphQL API, GraphQL API is going to send basically the schema to it. And say, okay, this is my schema, this is how request should look like, and this is how response will look like. The client then can basically store the schema, like in the case of GraphQL, and basically use it to validate the queries before they're sent to the client, to the server. Because again, like if you send invalid query to the server, why would you do that if you know that it's invalid? So there is no point in sending a valid request. Again, if you're a naughty person, and then you force bad request to the server, what server is going to do is just take your query, validate it according to the GraphQL schema basically of the API, and say, okay, is it valid or not? If it's not valid, it's going to send error right away. It will not do any type of processing, wasting CPU or memory. And this is a very nice feature, which again, is built into GraphQL. And this is again, a very nice thing, and a thing which is different than traditional REST APIs. If I talk about REST APIs, and especially advanced REST APIs, then I have to talk about HateOS. HateOS is basically the idea that your API is self-explanatory and explorable. If you think, you can think of it like a website. You know, when you go to the website, you just know the URL of a website, nothing else. But then you read the content, you follow the links, you go through the website itself. HateOS is the same idea, but for APIs. And this is exactly what I thought when I said, okay, like the GraphQL is advanced API. So let's look into it. Again, same URL, different tag. Okay. No, where's my, where's ED? Here it is. Okay, so we have some small changes, but not a lot. So what I did is, I created here a field called created by, and it will return the author. And if you open the post, eventually, yep, again, nothing changed here. If I look into post repository, nothing changed here. Last time query was returning the list of all posts, so again, nothing changed here. Yet if I go into my code, into my GraphQL, and again I need to refresh to get the new schema. Okay. So now I can say created by, and I get a name. And voila, it works. So I got information about the author inside the request for the post, although I didn't change almost anything. Well, I'm cheating, I changed one thing. So what actually I changed is that I added the new resolver. And this is the, just move this here. So I added basically post resolver. That's it. That's all the change. So I updated the schema and added the new resolver. So let's look at this resolver. So basically this resolver implements GraphQL resolver. If we look at the query, it was root resolver. So there's a difference. Query implements GraphQL root resolver, post resolver, GraphQL resolver, and we here basically added the type post. And again, funny enough, here we have method called created by, exactly the same like in schema, and it's take as an argument post, and returns back the author. So this is basically how my Java code knows how to interpret the query. Whenever it encounters the post in response and somebody asks for created by field, because created by field is not present in a post, it will find the appropriate resolver, in this case post resolver, and call appropriate method. And then that method will just resolve the field. So whatever you put here, it will be done. Okay, and that's it. That's all that's needed. Very small piece of code gives a lot of power to it. So if we look basically what we had, so I had my client and it was talking to the post. And then I added connection between the post and the author, so it meant that now whenever somebody requests the post, it can also request the author of the post. But why stop there? Let's continue. So let's connect author with the post with the comment with the post, and comment with the author. So we now have a very nice graph. And now you actually know why it's called GraphQL. Because you're creating the graphs between all the elements that you have. So let's look how that looks in the code now. Okay. Again, the same URL, just different tag. Okay. Wow, so a lot of stuff changed. So if we go back to schema, now you'll see a little bit more things that were not there before. So now the author has also field posts with array of posts. Posts have also comments with the array of comments. Comment head created by author belongs to post. And that's it. And again, if we go back to the GraphQL entry point, ignore the reds. Basically now we have more resolvers. So I added auth resolver, I added comments resolver, and also I extended the post resolver. So now post resolver also has comments. More or less the code is almost exactly the same like before. It's very simple. So if let's say open authors resolvers, yeah, auth resolver. Yeah, maybe not. I need to refresh. Yeah. Well, again, look, trust me, in a nutshell, it's exactly the same like it was before. So no many big different changes. So now when we go back to the original definition of the GraphQL, which says GraphQL is a query language for APIs, now it makes much more sense, right? Now we can understand what actually it means. Original idea behind the GraphQL is to be used in something like this. So you would have a user, basically the front end, which would actually hit the current GraphQL, which would then talk to a lot of different systems in the background. So different APIs, different systems, different databases, whatever. And then again, through the power of the query language which GraphQL gives you, you will expose all those information to the user and give a user a very nice and uniform way to actually go through the data and get the information which he or she needs. And again, GraphQL has a very powerful query language. And because it's very powerful, we're giving a lot of power to our end users, and we should always remember that. So again, another big difference between GraphQL and traditional REST APIs is that with GraphQL, we have very, very powerful query language. I didn't show you maybe even not half of the things that GraphQL query language can do. You can create basically the fragments of the code, which you can reuse. Then you can basically pass arguments, you can pass variables, you can change the name of the fields basically in response. You can create conditions. So if something is present, do something, or if something is present, skim subparts of the code. So the query language is very powerful. Another big difference between REST API and a GraphQL is that with GraphQL, client call all the shots. Just think about for a second. With traditional REST API, we as developers, we define which are the endpoints. We define what are going to be the parameters, what the response is going to look like. Everything is fully in our control. We know exactly where the user is going to hit us, how they're going to hit us, and what they're going to go back. With GraphQL, it's not the case. In case of GraphQL, you just say, okay, this is the things that I have, this is the connections between them, this is the fields which they have, and then basically ask what you need, in which way you need, how you need it. And this is a very important thing to remember. And I can demonstrate very easily why. So if we go back to my very simple example, you will notice that here I have a cyclic dependency. And you can say, okay, what's a big deal? Well, somebody can create a query like this, either by mistake or on intention. Important part about this query is, again, cyclic dependency. So it means that this query can go indefinitely. And imagine if somebody hit my current application with a query like this. It will definitely go down. And again, you might have users who actually create the query like this by mistake, but you have also the bad guys who will definitely want to do something like this. So you need to think about that and to be aware that with the GraphQL, your end users are getting much more power in their hands than they used to have with their traditional REST API. So how do we protect ourselves from the abuse? Well, there are a few ways that basically you can do it. One is just doing the timeouts. After a certain period of time, just send to the client timeout. This is the simplest thing to implement, but the least effective. Because imagine if somebody hit you with a very long and complex query, you're still going to crash your CPU and memory. Doesn't matter that you send the timeout to the client because your server is still going to die. The better thing that you can do is basically say which is the maximum query depth. If you remember, like I said, the first thing that GraphQL does when it gets the query is validate it according to the GraphQL schema. So during that validation, you can also very easily check, okay, what's the maximum depth of the query? If it's above a certain number, then I just don't want to do it. It's just too expensive. Done deal. So better protection than timeout, but you need also to work more for it. And again, it doesn't protect you if somebody attacks you in the width. And that's basically where the next one comes. So max query complexity. This is even better protection, but even more complex to implement. Idea is that for every part of a query, you say which complexity it is. And again, when you do the static analysis of a query, you sum all the numbers and say, okay, this number is just too big, it's too complex, I will not be doing that. The problem with this one is it's more complex to implement, but also it is very error-prone into maintaining it. Because you need to really know all the backend system things are happening, and again, if you come back to some part of a system and you change it after 1 year, you just need to remember, okay, how will that affect the query complexity? Another thing that you can do to protect yourself is do the throttling, where actually every period of time you just give certain amount of CPU and memory to a user. This is the best way to protect yourself, but again, the most complex way to actually implement. It's like the hardest one. And now we come back to the thing that I told you about GraphQL being a specification. Depending on the implementation that you use, certain of these things will already be baked into it, or maybe none of it. And in that case, you need to do all the work. So that's why it's very important to always be aware which implementation you're using, is it up to date, what does it give you, what things you need to build yourself. So let's talk a little bit more about GraphQL query. GraphQL query language consists of the three big parts. Part number one is basically querying, and it's read-only data, and that's something that more or less I showed you so far. The thing that you need to remember about this one is that because it should be read-only, never change your data for first. I saw people who actually in the get and read data, change the data, so don't do that. And the second thing is because it's read-only, it will be run in parallel. In most cases, again, depending from your implementation, but idea behind queries, because it's read-only, it can be run in parallel. No problems. Again, we also have a way to change the data. Because if you can only read data, it's not really that much fun, right? What can you do with only reading the data? It's just a limited part of things. And that's where actually mutations come in place to change the data. And again, because mutations are changing the data, by default, they will be sequential. So again, let's look at the example of that one. Again, same URL, different tag. Remember? Yes, I do remember. Go away. So, important part here is, again, schema, right? Like I said, schema is mandatory. It's the heart and the base for your API. So here I added mutation. Important thing about this name, query and mutation, you can use whatever you want to use. It will still work. But please, for the God's sake of everybody, just use the standard one so that everybody understands what we're talking about. So for reading, query, changing mutation. So I have mutation, type mutation. And again, it's exactly the same like all other types. Above, no difference. So we have type mutation, we have add author. And here is basically the new thing that I didn't show so far. Here I'm adding the parameter. And I'm saying, okay, the add author has a parameter of name, and type string. And again, because there's exclamation mark, it means it's mandatory. You can add parameters wherever you want. So you can add them also in the reading the data, mutation of the data. You can even set the default values for them. So parameters are not available only for mutations. You can use them throughout the whole GraphQL schema. I'm going to return back the author. And again, here I have also removed the author. So I'm going to take parameter of ID, type ID, mentor again, and return type of author. Again, the changes that I need to do to my code is very minimal. So into GraphQL entry point by servlet, I just added one more resolver, mutation. That's it. So if I open mutation, again, it implements GraphQL root resolver. So exactly the same like a query. Like I said, we have two types of resolvers. The top resolver, basically root resolvers, and the all other ones. In this case, mutation and query are the top ones, so that's why they're GraphQL root resolvers. Again, I have a method called addAuthor, exactly the same like in my schema. Parameter name of the type string. It's going to return the author, and again, remove the author, the same thing. Did I start this? Yes, I hope. So basically, if we go back here, okay, so now, okay, let's first just see that I don't cheat. All authors. Yeah, I also added the old authors so that I can show you this. Name. So this is the old author that I have at the moment. So let's add one more. We just add like this. Okay. Of course, that's France, right? And we want back ID and a name, because we will going to get the full object of author when we run it. Okay, here it is. So let me just remember this one. So if I go back and ask for all authors, I'll just go with name, yeah, it's going to be easier. Voila, it's all there. And also, of course, I can remove the author, but I will not be showing that why now. So that's it about mutation. Basically, like a very simple thing. Not very different from the queries. The last part of the GraphQL language, the third part, is subscriptions. The idea behind the subscription is very simple, and that is The client comes and say to the server, okay, I want the stream of this type of messages, and basically you create almost exactly the same like a query, and then the server constantly sends back the full stream of messages back to the client. GraphQL originated from Facebook, and I think that everybody can figure out, okay, what was the actual need for subscription in the case of a Facebook. Again, important part, the GraphQL specification. Not all implementations implemented subscription. So most of them have query and mutations, not all of them have subscription done. So again, you need to remember which implementation you're using. So you can basically now start to ask yourself a few questions about GraphQL. The first thing is, okay, but what do we do about error responses, right? Because with the REST, we usually depended on the HTTP responses, and then we went to like 404s and all other things. Well, again, GraphQL is a specification, so somebody already thought about all kind of things regarding that part. So you don't have to really break your head about everything, but you will still need to do some work. So if I go back to my example here, you see that when I requested the data, I have here basically the data, and data is here. But let's put some field that I know that's not there. So it's definitely not there, right? Well, then you see you get something like this. Error, and then additional information here. So by default, the data will come into data part, all the errors will come in the errors part. Again, you can also customize these errors, make them more user-friendly, tweak them, change them according to your needs. Again, depending on how your implementation is done. So some things you still need to do, but a lot of things are already taken care of for you. So the next thing that you can very easily see if you actually saw my example is that, let's imagine that in my case, I have one user, author, which created like hundreds and hundreds of posts. And I ask for all the posts and want the author for all the posts. I'm going to basically destroy my database because I'm constantly going to call it and call it over and over again. For every post, I'm going to call, get me the author, get me the author, get me the author, which is not really the best case, right? So when it comes to performance and actually caching, GraphQL doesn't really care that much. It's basically up to the implementation at your choosing and your own thinking about how to actually solve the problem. Maybe the implementation that you would use would already optimize it for you. Maybe it will not do anything, and then basically just say, okay, well, you know what? You figure it out. You're a developer. You know what you want from your application. So again, you need to be aware of that. Okay, but what if we want authentication and authorization, right? Because not on all APIs are publicly available. Not all information and all endpoints should be accessible to everybody, right? Well, again, from the GraphQL point of view, GraphQL doesn't really care. Again, it's up to you. You need to figure it out. Again, some implementations will do almost all the work for you, and you just need to do some small bits and pieces and just say, okay, which thing needs to go where? Somewhere you need to do more work. Again, depends from implementation to implementation. Most of them are relying on more or less the similar solutions that the REST APIs are using all over the place, and that's basically the context, the cookies, session, and other things. But again, maybe the implementation did a lot of work for you, or maybe didn't just did the minimum one, then you basically need to do the rest. Again, you need to be aware of that. So let's summarize with GraphQL versus traditional REST API. Well, as you saw, they're very similar. If we go according to the REST definition, we can argue that the GraphQL is a full-on REST API. So they're very, very similar. But again, there are differences. Maybe subtle, maybe not so subtle, but there are differences between them, let's be honest. When it comes to tools and knowledge, again, I think this is a very big gap. And for a reason, REST is like present for a very, very long time. We were building something according to the REST APIs long before it was even defined as a REST. So the tools, the knowledge, the frameworks, the libraries, everything ecosystem around it is very old and very battle tested and very large. GraphQL is still relatively new technology. It's not that widely used as a REST. So of course that the tools and the knowledge are lacking behind it. That's just a fact. But of course, it's becoming better and better every day. The very nice thing about this is that because GraphQL and REST APIs are so similar, that most of the so-called old tricks from the REST world, you can just take and put in the GraphQL world, and it will work automatically. It will work for free for you. In some cases, you need to do a little bit of tweaking, this and that, but again, with the common sense and understanding of actually how the GraphQL works behind the scene and basically what are the differences between GraphQL and the rest, it won't be that difficult for you to actually figure out how to do it. Additional thing is that GraphQL has extremely rich SDL, or schema definition language, if you want a longer name. Again, I developed REST APIs for a long period of time now, so I used all kinds of specifications. I used Swagger, I used an Open API spec, I used Drummel, I used API Blueprint, which are all very good and nice tools for REST. But I must say that the GraphQL schema definition basically beat them at the moment. It's much more concise, it's much more compact, but much more powerful. For example, I didn't show you how to extend the scalars. So you can basically you can use any scalar that you think of, especially if your backend system supports it. And that's very easy to do with the GraphQL. Again, you can also define interfaces in your schema. Another very nice feature. Another feature which also blew me, because in one case I really needed it and I had troubles with it, and that's basically unions. Creating basically unions, and that means basically it's like either A or B or C or D or whatever. Creating something like that in, let's say, all tools, it's a little bit more tricky. It's more challenging. With the GraphQL, it's one line, and you're done. So schema definition, which actually I showed you, is just a very small subset of it, and it's extremely powerful and rich. And I really recommend to read it. It's not that long to read, and it's really powerful. Another one, like I said, is extremely powerful query language. Again, I didn't show you all the possibilities of it. I didn't show you how to actually put arguments into it, how to actually put variables into it. I didn't show you how to make the fragments of it, how to actually put conditions into it, how to rename the fields, but there's a lot of things there that you can actually do. Of course, let's be honest, it's not like SQL, so you can't do the grouping and all other things, so it's not on that level, but nevertheless, it's on a very, very good level, and it's very rich, and it's very powerful. So, merci. I have 2 minutes for questions, if there are any questions. Yep.
Is there any reactive implementation?
The question is there any reactive implementation? Well, it comes from the Facebook. So guess what? It's in React.js. So if you want to JavaScript, it's already there. For Java side, I must say that I don't know one. But again, they're popping up all the time. For other languages, I don't know. Does that answer your question?
Yes.
Any other questions? Okay.